Hello everyone, my name is Emeninta Angelina Pelawi. I am a student in Medan State University, Faculty of Math and Science in Physics Study Program 2021. In this video, I want to show you the experiment that I made. It's about the moment of inertia of the cylinder on an inclined plane. I hope you enjoy my video and thanks for watching. Experimental purpose of this practicum are as follows. First, knowing the effect of the length of the inclined plane with the resulting moment of inertia. Second, analyzing the moment of inertia in everyday life, how an event is said to have a greater moment of inertia. Third, knowing the relationship between the length of the inclined plane, time, mass, radius of the object, and the slope angle of the inclined plane so that the moment of inertia that occurs is greater. Fourth, evaluate which type of inclined plane length has the greatest moment of inertia. Fifth, apply the relationship between the length of the inclined plane, time, mass, radius of the object, and the slope of angle in the inclined plane so that the moment of inertia is useful in everyday events. 6. Can make or find similar experiments related to the moment of inertia. Theoretical review. Inertia is the tendency of an object to maintain its state, stay still or move. Objects that are difficult to move are said to have great inertia, like a vase. The Earth, which is always in the state of rotation, has rotational inertia. So, the moment of inertia is a measure of the magnitude of the tendency to rotate, which is determined by the state of the object or its constituent particles. We can encounter rotation in everyday life, such as rotating vessels, wheels on flat roads, uphill roads, and hillsides or mountains, as well as landside on hillside or mountains. In rotational motion, the moment of inertia of a rigid body has an important role in the dynamic of the body. One example of the dynamic of a rigid body is the motion of a rigid ball down in an inclined plane. The cylinder undergoes rotational and translational motion. Cylinder can also undergo rotational and translational motion when tilted downwards. In this motion, the coefficient of kinetic and static friction can be measured. In addition to the coefficient of kinetic static friction, the moment of inertia coefficient of the cylinder can also be measured. If a cylinder is relaxed without initial velocity on Roche's inclined plane of inclination theta, the object will roll. The force acting on the object is according to the following equation is, we substitute equation from the fourth equation into third equation so that the following equation will be produced is moment inertia is equal to time squared times the gravitational times sin theta minus mass times acceleration divided by 2 times the distance times the mass times the air squared, with the E is the moment of inertia with the unit of kilogram meter square, M is the cylinder mass with the unit of kilogram, R is the cylinder radius with the unit of meter, T is the length of time the cylinder moves with the unit of second, S is the distance traveled by the cylinder with the unit of meter, and G is the acceleration due to gravity with the unit of 9.8 meter divided by s squared, and the theta is the plane inclined angle. For tools and materials we need are first, adjustable inclined plane, second, a cylinder, third, rule, and fourth, stopwatch. Part 5. Work procedure. The work procedure are first, weigh the mass of the cylinder with a balance. We get the mass of the cylinder is 0.3 kg. Second, measure the diameter of the cylinder with a ruler. We get the diameter of the cylinder is 8.5 times 10 to the power of -2 with the unit of meter. And third, set the slope of the plane to form an angle theta is equal to 30 degrees. Fourth, measure the length of the inclined plane with a rule. Fifth, remove the cylinder from the specific distance. Sixth, record the time it takes with the stopwatch when the ball is released to the bottom of the inclined. The first experiment is in the inclined plane with the 30 degree, where with the mass of cylinder is 0.3 kg. First, we put it with the distance of 50 cm, and in the distance of 50 cm, we calculate the time it takes to fall with the stopwatch, and we get the time is 0.5 seconds. In the experiment number 2, we put the cylinder in the distance of 20 cm. In the distance of 20 cm, we get the time it takes is 0.53 seconds. Next, in the third experiment, we put the cylinder in the distance of 25 cm. In the distance of 25, we get the time it takes is 0.56 seconds. Next, in the experiment number 4, we put the cylinder in the distance of 30 cm. In the distance of 30 cm, we get the time it takes is 0.74. In the fifth experiment, we put the cylinder in the distance of 35 cm. In the distance of 35 cm, we get the time it takes is 0.78 seconds. Next is we calculate the moment inertia of the cylinder in inclined plane with the angle of 60 degrees. First, in the sixth experiment, we put the same mass cylinder with the mass of 0.3 kg. And in the sixth experiment, we first put it in the 50 cm distance, and we calculate the time it takes to fall. We get the time it takes is 0.43 seconds. In the seventh experiment, we put it in the distance of 20 cm. We get the time it takes is 0.39 seconds. Next, in the eighth experiment, we put it the cylinder with the distance 25 cm. We get the time it takes is 0.28 seconds. Next, in the ninth experiment, we put it in the 30 cm distance. We get the time it takes is 0.48 seconds. And the last experiment, we put the cylinder in the 35 cm. In the 35 cm, we get the time it takes is 0.53 seconds. Have the experimental result and discussion shown in the table. We calculate the speed and acceleration from the time we get like the table. And from the table, this experiment is entitled The Moment of Inertia, which consists of 10 different experiments. In the experiment, namely determining the moment of inertia of the object in the theory, in the first experiment, the practitioner measures the height, mass, diameter, time, and acceleration of each object or sample. The solid cylinder have the same mass, it's 0.3 kg, and have diameter of 8.5 times 10 to the power of minus 2 meter. The solid cylinder has a different moment of inertia. Therefore, the greater of the mass, diameter, height of an object, the greater of the moment inertia it has. In the first experiment, if we know that the mass is 0.3 kg, diameter is equal to 8.5 times 10 to the power of minus 2 meter. For angle is 30 degrees. We get the moment of inertia like the table, like shown in the table and graph. And if we know that mass is same as 0.3 kg, diameter is equal to 8.5 times 10 to the power of minus 2 meter. For angle 60 degrees, we have the moment inertia like the table and is shown in the graph in the table. Next part is about conclusion. From this practicum, it can be concluded that first, the mass of an object is directly proportional to the angle of the deviation. The greater the mass of the load or object, the greater the deviation of angle and vice versa. Second, the moment of inertia is affected by the shape of the object or constant, the mass of the object and the radius. Third, the farther of the object is from the rotary axis, the longer it takes to achieve one vibration, and the resulting period will be greater and the object will be more difficult to oscillate. Fourth, the period of an object is directly proportional to its moment of inertia. The larger the period, the greater the moment of inertia, and vice versa. The smaller the period, the smaller the moment of inertia. Fifth, the mass of an object is directly proportional to its period. The greater the mass, the greater the period, and vice versa. And last, the greater the mass, diameter, and height of an object, the greater the moment of inertia, then the object will be difficult to move, or the object will be more difficult to change its angular speed. Okay guys, thank you for watching my video about the moment of inertia of the cylinder on an inclined plane. And I hope this video will give you some information that may be helpful in the future. See you!